open your book to page 165. Today's lesson is on rational functions. Rational came from the word ratio. Ratio means like a fraction. So rational function, if you go to page 169, and this is an example of rational function, it's a fraction. Okay. Now, when you're doing a rational function, there are certain characteristics you need to be aware of. So first you need to do is worry about vertical asymptotes. So first you need to get the vertical asymptote. And to get the vertical asymptotes, we're just going to call it VA. So the vertical asymptote, you look at the denominator to see what is the restriction. So like, for example, like this, like number 11 over here, this one, x equal to 0, will make this undefined. So that is your value that's not allowed. So that would be your asymptote. So in this case, you're going to have the vertical asymptote of x equal to 0, x equal to 3, and x equal to negative 2. So that would be your vertical asymptote. Okay. And for this one, you have to go and do the factoring. Okay, and then from there, and you go from there. And like this one, you're going to have vertical asymptote. This is a double vertical asymptote. We're going to cover more of that later on in the next lesson. But this one, you're going to get vertical asymptote of x equal to 1, and so forth. So first, you go and get your vertical asymptote. The next, what you want to do is you want to go and get the horizontal asymptote. And we're going to just call it HA. Okay. Now, horizontal asymptote, it came from the theorem on the bottom of page 167. If you look at on the bottom of page 167 over here, so over here it tells you what kind of asymptotes that you're going to have. So basically what you do is you're comparing the degrees or the exponents. So n stands for the numerator, d stands for the denominator on their degrees. Okay? So if the n is greater than d, means the top is higher degree. So that means that that means there is no horizontal asymptote. Okay? So you can basically what they're saying is that the horizontal asymptote applies to when the x equal to a very large number, like approaching infinity. Okay, very, very large number. Okay, so what happens is when x is really large, then it would depend, the value of y would depend on the highest degree. So the lower degree is not going to matter. So let me give you some examples. Okay, so that again, let's go to next page over here. Okay. Okay. So for example, like this one, right? Let's say when x equal to like 1,000,000, right? Let's say x equal to 1,000,000 over here. Then 2 and 3 is not going to make much of an effect. It's going to be insignificant. So that means you don't have to worry about this. You can just you can just ignore that. Again, we're looking at the asymptote. Asymptote is when x equal to extremely large value, like approach to infinity. So in this case, this is gone. Right? You can just ignore that and just focus on you can just focus on this part over here. So when you divide, you're going to get, so notice that x, when you divide, you're going to get x to the 0.1 power, and if x equal to like infinity, you're going to have x equal to infinity. So in this case, if the top exponent is higher than the bottom, then you will have no horizontal asymptote. Okay. Now in this case, if you look at 17, if they are the same, if they are equal, again, let's say x equal to like a billion or a trillion, right? Then the 5 and 7 is not going to make a difference. So you can just ignore that. And notice this will cancel out. So if they're the same degree, okay, if the top and the bottom have the same degree, they're going to cancel out, and your horizontal asymptote would be just 5/3. Okay? So again, if the top is bigger, no horizontal asymptote. If they're the same, they will cancel out, and whatever the coefficient would be your asymptote. Okay, now, over here, if the bottom is bigger, again, we don't have to worry about this because, again, when x equal to like a trillion, this is not going to make a difference. Okay, so those you can just ignore that. But again, over here, notice if you cancel, you're going to get x on the bottom. So if x become like a really large value, you're going to get 1 over a very large value, you're going to approach to 0, right? Or if you think of it infinity, if x approach infinity, you're going to have 1 over infinity, which will equal to 0. So if the bottom is bigger, okay, you're going to have y equal to 0 as your horizontal asymptote. So you can sum up, if the top is bigger, okay, again, the exponent of the top is bigger than the exponent of the bottom, then this will have no horizontal asymptote. If they're the same, they will cancel out. So this one, horizontal asymptote will be just 5 over 3. Okay? Now, if the bottom is bigger, then you're going to have 1 over infinity, you're going to equal to 0. So y equal to 0 would be your horizontal asymptote. So that's what. So they got 3 cases over here. Okay? So that's how you figure out the horizontal asymptote. Okay? Then after that, next you need to do is you need to go and figure out the next thing you want to do is you want to figure out the X-Intercept. Okay? X-Intercept is when y equal to 0. So you set y equal to 0 and you can look for X-Intercept. Okay? And next you need to do is you need to get a Y-Intercept. Okay, Y-Intercept is when x equal to 0. So you need to get those 4 get this 4 information and you sketch it out. Okay? So let's go over the example. Let's go to page 167. And let's go and do example. And let's go to page 165. And let's do example 1. Example 1, you have the x squared y minus 4y equal to 8. So what you need to do first is you need to go ahead and get the y on one side and everything else on the other side, so you can get the function in the correct form. So go and factor out the y. So you get x squared minus 4 equal to 8. And then you divide, so y equal to 8 over x squared minus 4. Then you have to factor, so y equal to 8 over x plus 2, x minus 2. Okay, so again, so first you get your vertical asymptote. So vertical asymptote is going to be x equal to negative 2 from here, and you're going to get positive 2 from here. Then you have to get your horizontal asymptote. Okay, let's do this. Let's do it this way. Okay, horizontal asymptote is going to be y equal to, remember horizontal asymptote, you look at the degree, right? Let's look over here. Okay, so over here the bottom is higher, so when x equal to infinity, you're going to have an 8 over infinity, you're going to equal to 0. So y equal to 0 will be horizontal asymptote. Okay, next you want to get X-Intercept. X-Intercept is when y equal to 0, so you're going to, when you set this equal to 0, so again, if you set this equal to 0, you cross multiply, you got 8 equal to 0, which is impossible. So this, in this case, there's none. Okay, so again, you set y equal to 0 and you solve for x. So what you have is you set y equal to 0, so you have this situation. You cross multiply, you're going to get 0 equal to 8, so cannot, so that's none, right? Impossible, right? So number 4, Y-Intercept. Okay, Y-Intercept is when you set x equal to 0. So easier if you use this one over here. Okay, so again, this is when x equal to 0, so you're going to get y equal to 8 over 0 minus 4, right? Using this one here. Okay, this is easier than this one. So that's why both are useful. Okay, so you got y equal to negative 2. Okay, so y equal to negative 2. So that's your Y-Intercept. So once you get all this information, then you're ready to go ahead and do your sketching. Okay. Okay, so vertical asymptote is negative 2. So 1, 2. by the way, nothing is allowed to touch the vertical asymptote. But horizontal asymptote, it's okay to touch horizontal asymptote in the middle region. But again, horizontal asymptote is for the two extreme edge, okay, to the regions. So it's okay if you cross the horizontal asymptote in the middle. Okay. So again, horizontal asymptote is for the two outer regions. Okay, so that's your two vertical asymptote, horizontal asymptote. Since there's already none over here, it's kind of harder to see. So I'm going to use this one too. Use this one too. Okay, so that's your horizontal asymptote. And your X-intercept, there's none. So it means the graph does not touch the X-axis. Okay. And Y-intercept is y equal to -2. Okay, so now you have to sketch your graph based on this information. Again, there's no X-intercept, means X does not cross over. That means that's how you know it does not go this way, because there's no X-intercept. Means it does not cross the X-axis. So that means this cannot go this way. That means this has to go this way. Okay? Again, from here, it cannot go this way because there's no X-intercept. Means you have to go down this way. Okay? And when you have vertical asymptote, the graph will always go opposite direction. So if this is going down this way, this will go up, right? This goes down, this will go up. They always go opposite direction. If you have the double, if this is like a square, if the vertical asymptote is double, then it will go the same direction. So again, if the vertical asymptote is single power, it go opposite direction. If it's even power like a 2 or 4, it will go in the same direction. So again, you're gonna come across those later on. So again, this side is going down, so this will go up. Okay, and again, remember, the graph will always approach asymptote, right? And notice it does not cross over. That's because there's no X-intercept, means it does not cross over. So this is very important. It give you, so you have to use this clue to get your graph. Okay. Okay. Let's go to example 2. Let's go to page 168. Example 2. You have y is equal to x plus 3, x minus 1, over x plus 1, x minus 2. Okay, so first, you want to get the vertical asymptote. So vertical asymptote would be x equal to -1 and positive 2. Right? From here you get -1, from here you get positive 2. Then you get the horizontal asymptote. So this is, on the top, you have x squared, right? If you multiply out, you're going to get x squared. And on the bottom, you're going to get x squared. And since they are the same, you're going to have x squared over x squared will give you 1. So y equal to 1. Right? Again, they have the same degree. You got x squared on the top, you got x squared on the bottom. So you got x squared over x squared will give you 1. Okay. Next one, you're going to get the x-intercept. X-intercept is when you set y equal to 0, right? So when you set y equal to 0, you're going to get 0 equal to x plus 3, x minus 1, x plus 1, x minus 2, right? But notice when you cross multiply, if you cross multiply, you're still going to get, so you don't have to worry about the bottom. The x-intercept, when you cross multiply, you're still going to get 0. So the only one you have to worry about is the top. Okay, again, when you cross multiply, you're going to get these. So that means in the future, when you're looking for x-intercept, just look at the top. That's what you have to do. Okay? And so x-intercept, you're going to get, from here, you're going to get -3. From here, you're going to get 1. Okay. And then you're going to get the y-intercept. Y-intercept is when x equal to 0. So if you set x equal to 0, you're going to get y equal to, so you can put a 0 in here, you're going to get 3 times -1 over 1, -2, right? So this will equal to 3 over 2. Okay. So again, that's all those are all your information. Now go and start to sketch the information. So vertical asymptote, x equal to -1. So that's the y, this is the x. Okay, so that's your X-intercept, and next one is 2. So you sketch 2. Okay, so that's your vertical asymptotes. And horizontal is y equal to 1. Okay, and now let's go and plot the X-intercept. So it's -3. And then you have +1. And the Y-intercept is 3/2. 3/2 is 1.5. So it's right over here. Okay, so that's all the information that you have. Okay, now remember what I say, right? Horizontal asymptote is for the two extremes. So it's not for the middle part. So it's okay to cross over the horizontal asymptote in the middle. Since you got 1 point here, 1 point here, so you know your graph is going to go this way, right? Okay. Now, since the graph, this is going up, so this has to go down, right? One go up, one go down the opposite direction, and there's an intercept over here, so this is going to go like this. Okay. And this is going down, so this will go up, and so this will go like this. Okay, and so that's your sketch.